In this video, we're going to be doing a little bit of review of the process of science and then focusing in on variables and groups that are important for experimental design. So I know that you talked a lot about the nature of science back in chemistry, so let's do just a quick review of that. Take a minute and try to remember for yourself, what is the difference between a theory and a law in science? And also you could add a guess. So what is the difference between those things? The important thing to remember here is that theories and laws are different, but laws are not stronger than theories. They're just different than theories. A law is a description of what will happen in nature. So it's kind of something you can use to make a prediction. If I lift up my pen and let go, it will fall. And that can be described by the law of gravity. Oftentimes, laws will involve some sort of mathematical equation. So if you think back to physics, you should have learned about Newton's laws of motion. For example, F equals ma. So that's a math equation that's used to make a prediction about how things are going to move. Now, a theory is an explanation for why something happens. We notice that something is happening in nature, and we want to know, well, what's causing that? The important thing about a theory is that theories require a lot of evidence, so there needs to be experiments that back up and support this theory. It's not just a guess. Right? A theory is not just a guess. So if there's one thing you remember from science, please try to remember that. And then an example of a theory would be the theory of evolution. So here's a nice little graphic that sort of reviews the process of science. Now, not all science is going to follow this exact series of steps, but a lot of science does, and it's a good idea to base our understanding of science around. So we start with a question. We want to find something out. Then we do some research on that question. Then we construct a hypothesis, which is sort of a prediction, not really a guess, stronger than a guess, but not as comprehensive or strong as a theory. Then we need to test our hypothesis with a carefully designed experiment, see if our experiment is working the way we thought it would or not. If it's not, then we might need to fix our procedure. If it is working, then we can look at that data and draw conclusions, try to find an answer to our question, and then we can say, was this what our hypothesis predicted, or was this not what our hypothesis predicted? And if it wasn't, then maybe we need a new hypothesis and we need to test that hypothesis. And if it was, maybe those results can be published in some kind of scientific journal. So this is a general process of science. In this video now, we're really going to focus in on the experiment itself and what we need to keep in mind when we're designing that with regards to variables. So let's use an example, simple scientific experiment that we want to do. I want to know whether or not this Miracle-Gro tomato plant food, this fertilizer, actually works. I want to know, is it actually going to make my tomato plants grow taller than if I didn't use it? So now you can pause the video and think for a minute, maybe try to outline just a basic plan. How could we test this? So not a full, detailed procedure, but just a general idea of how you might test that. So my general procedure might be something like, I'm going to grow some plants with this fertilizer, and I'm going to grow some plants without it. And then I'm going to measure the plants, right, and see how tall they are. So that's my general idea for how this experiment is going to go. So maybe if you wanted to test if the Miracle-Gro plant food actually works, maybe your idea would be, well, I'm just going to grow some tomato plants with it and see if they grow tall. And that might be something you might do in, regular life. But for science, we need to have what's known as a control group for this experiment. The control group, you could think about it as kind of the normal group, the one without the thing you are trying to test. Not every experiment is going to have a control group, but a lot of them will, especially if you're testing like how effective a certain maybe medication or a certain treatment is. You definitely need a control group. The control group is being compared to the experimental group, and that's the group that gets the thing you're trying to test. So if we were testing a new medication, for example, you would give some people the medication and you would not give some people the medication. So the people who got the medication would be in the experimental group. So the point of some experiments that have control groups is you need to be able to compare these two groups and see if this experimental group is actually different than the control group in the results. You could think about it, if I just grow plants with the fertilizer, how do I know that the fertilizer was the reason that they grew taller? Maybe they would have grown that tall anyway without the fertilizer. Maybe they would have grown taller without the fertilizer. I don't know unless I grow some with the fertilizer and some without the fertilizer. So now take a second and think about our tomato experiment. You can pause the video again. What would our control group be and what would our experimental group be? So hopefully you came up with our control group should be the plants that get no Miracle-Gro, and the experimental group should be the plants that get the Miracle-Gro. Now we're going to talk about variables, different variables in a science experiment. And a variable, if you didn't know what a variable is something that can vary. It has the word vary right in it. So something that can vary. And specifically, we're going to look at 3 different types of variables, the first being the independent variable. So the independent variable in an experiment, every experiment needs to have an independent variable. And usually this is the thing that you are changing in the experiment. Sometimes it's called the manipulated variable. So it's the thing that you are intentionally varying to make your different groups in your experiment different. It's important, again, that there should just be one. For any given experiment, you should only have one thing that you're changing. Now, this explanation works most of the time. There may be some experiments in which you are not directly manipulating something. For example, if you're looking at something, how it changes over time. Your independent variable might be time. So this will work in most cases, but there might be some experiments where it's not exactly clear what the manipulated variable is, and really it's because it's not being manipulated. Another way to think about this, though, is look at your question that you're researching. If it's something along the lines of, what is the effect of blank on something? This blank is your independent variable. So now take a minute and think about the tomato experiment. What would the independent variable be in that experiment? So the independent variable in this experiment, the thing that I'm manipulating and changing, is going to be the fertilizer. We'll say fertilizer, yes or no. Whether or not the plants get that fertilizer. And I can test it out on this one. If I think about what would my question be for this experiment, it's probably something like, what is the effect of fertilizer, ... So the fertilizer goes into this, what is the effect of, so that's going to be my independent variable. The sort of partner of the independent variable is the dependent variable. Usually you can identify this because this is the thing that you are measuring or observing during the experiment or at the end of the experiment. It's kind of what you would think of as your results. The real test is that the dependent variable changes because of the independent variable. That's why they're named that way. The dependent variable depends on the independent variable. So for the tomato experiment, now what is our dependent variable? What's the thing that we're trying to find as our results? So I would say that the dependent variable in this experiment is the growth, or you could say the height of the plants. How tall do the tomato plants get? And we're saying that how tall the tomato plants get changes because of the fertilizer. So the growth of the plant, our dependent variable, depends on the fertilizer, our independent variable. So now here are some practice questions with these variables, some different sample experiments. This one says, a researcher would like to know whether men and women experience jet lag differently. He surveys people traveling from San Francisco to New York to measure their feelings of sleepiness and distortion upon arrival at their destination. So go ahead and pause the video, try to fill these out. What's our independent variable? IV is just an abbreviation for that. What's our dependent variable? DV. And then what are some controls? So some control variables that you want to keep the same for all of your groups in this experiment. You can just think of a couple examples of those. So the independent variable ought to be sort of men versus women, or we could say it's gender. So note that this isn't something that we are directly manipulating, right? We're not changing the gender of people. But if we say, what is the effect of, the thing that we're looking for the effect of is the gender of these people. What is the effect of the different genders? And then the thing that we're looking for, what is it affecting, is jet lag. Or specifically, we could put in here their feelings of sleepiness and distortion upon arriving at their destination would be our dependent variable. So we're saying, how does gender affect jet lag? Some controls that we would want to put in there. So for our groups of men and women, I would say we want to make sure that they're flying in the same class, right? We wouldn't want to be comparing first class passengers to coach passengers because that might make a difference. We might want to control for what airline they flew on. If one group was flying all on one airline and another group was flying all on a different airline, maybe that might make a difference. We'd probably want to control for the time of day that they were flying. You know, if some were flying in the morning and some were flying at night, that might make a difference. And there's other variables that you could definitely think of for controls too, but these are just a few examples. Remember, the point of the control variables is to make sure that the reason the dependent variable has changed is only because of the independent variable and not any other factors. We want to know the only thing that we're looking at, the influence on jet lag, is gender. We don't want to know how is class affecting jet lag, how is airline affecting jet lag, how is time of day affecting jet lag. We only want to be looking at this one thing. And so these controls are to make sure that we're only looking at that one thing, the independent variable. And here's another example experiment for practice. A science teacher wants to test the effectiveness of two types of learning strategies. She uses a flow chart in her first period class and a mnemonic in her fifth period class to help them remember the content. She gives the same quiz to each class to examine their ability to remember the information. So go ahead and pause again and try to identify the variables in this one. So the independent variable, in this case, it is something that the experimenter is manipulating, and that would be whether she uses a flowchart or a mnemonic. That is the thing that she is changing between the classes. And for the dependent variable, so we were trying to look at the effect of using a flowchart or mnemonic on the student's ability to remember the information. So I would say that's probably going to be measured as their quiz scores, or you could say their ability to remember the information. So what is the effect of using these strategies on the student's quiz scores? For controls, the big one is right in the problem. She needs to make sure to give both groups the same quiz, because if she gives one group a harder quiz, they might do worse than the other group, and it would have nothing to do with what kind of flowchart or mnemonic they got. I would also say she should give both groups the same directions. She should give them the exact same instructions when they start the quiz. Also, she'd probably want to give them the same amount of time to complete the quiz. If one group gets a longer amount of time, then that might affect our results. And again, there's other things you could put in here. If I were to critique this experiment, I might note, well, maybe her first period class is earlier in the day than her fifth period class, and that might have an effect on the results. Or maybe her first period class has a different, student makeup than the fifth period class. So I would say this isn't a perfect experiment, but still there are things she can do to ensure more control over it. All right, that's going to be the end of this video. We will look at it more in class together next time.